Hey guys, welcome to Codeforces Everyday until GM, day 73. Did not do too good on my contest or practice contest yesterday for my club. So today we are gonna solve B, and then we're just gonna do problems until I get tired enough to sleep. So might be a bit of a longer video today. A little bit inspired though. You always have to bounce back whenever you don't do very good. So it makes me realize that I need to try a bit harder because for the past week I haven't really been posting these daily videos as I was before, right? Let's fix that. Um, okay. Accurately, Lee was cleaning his house for the party when he found a messy string under carpets. He would like to make it string and make it clean accurately and in a stylish way. The string S he found is a binary string of length n. In one move, he can choose two consecutive characters. If S1 Si is a 1 and Si plus 1 is 0, he can erase exactly one of them. Okay. Lee can make an arbitrary number of moves, possibly 0, and he'd like to make the string as clean as possible. He thinks for two different strings, X and Y. The shorter string is cleaner if they're the same length. The lexicographically smaller string is cleaner. Now you should answer t-test cases. Okay. So basically we're given a string and we want to shrink it as much as possible with this rule, right? So it's taking some input, and we're taking an N, and we're taking an S. So remove this. So I've already gave some thought to this problem during the contest, and I think I got pretty close, but then I went to go play board games, and now I'm back here trying to upsolve. So I think here's how you're supposed to do this problem, right? So zeros in front always stay, and we can merge like ones and zeros. Like, for example, 1 or 1 is like our minimal case. If we have like however many zeros in between two ones, we can merge all those zeros into 1 0. And if we have like a bunch of ones in between two zeros, we can merge all these into 1 1. So now we have 101, right? 101, from our rule, we can merge it into this, or we can merge it into this, right? By removing either the 1 or the 0. But this is smaller, so we want to turn 101s into 01. So here's my idea. We split the string. Let's just have like 0 0 1 1 0 0 1 1 0 0 into groups where we have 0 0 1 1 0 0 1 1 0 0, right? And then every group we will just call it what it is, 0 1 0 1 0. And for every group of 1 0, we replace that with 0. I think. Let me think about this. Let's add one more group here, because then we would be 0. So we keep all the leading zeros, like these will always be here. We merge to 0. We merge because this will eventually become, it's like this, right? We can merge this into 101, which is just 0 1. And this 1 is part of the next group, so we can merge it to 0. And then now this is 1s and 0s. We do this again, merge this to 0. And then we keep however many 1s we have left. Now, say these 1s didn't exist. right, and we just had these zeros, what would it do? We merge these to 0, and then we have 100, which at best becomes 10, then 0. So this we can just merge to 0 as well. Then it'll just be all zeros, which should be correct. So I don't think we actually need to track the second array here. We just need this one, and we check the first index of it. So we need to put the string on character change. We can do that with a for loop. We should track the current character groups, and then char cur equals s0 for 1 for I in range 1 when 1 in track a cur group. We don't need this. If cur group 0, the cur group 0 should be s0. Like this. If cur group 0 equal to si, cur group dot append si, else groups dot append cur group equals si. Groups. And then at the end we should append cur groups. Okay, 0, 0, 0, and all the ones. 0, 1, 0, 1. And then this one, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, and all the zeros. And 1. Okay, I think this does exactly what I want it to now. Now what I need to do is print, okay, to print equals cur group, equals groups 0. Well, okay, we should track a to print. If groups 0, 0 equals 0, to print dot append groups 0, and then for groups. Okay. Prev group. Just call it prev. Prev equals. We'll basically redo this logic here, I think. Groups. Else. 0. Oh, if it's not 0, 0, it's going to be 1. For I in range from 1 to len groups. Well, we greedily replace 1, 0 with the zeros. Right, so if prev equals 1, oh, these are strings. And groups I 0 equals 0. Print dot append 0. This is an array. I should do dot join and this, and then do we even care about 1? 0, it's going to be a 1 anyway, so we just check if the current group is equal to 0. If it is, we set it to 0. If it's whatever. this. Okay, I need to rework this logic. Something's not right here. So what are we doing? We're keeping the leading zeros. If there's no leading zeros, we do something else. But this behavior should be the same regardless. So we should have one for loop for I in range from 1 to len groups, right? And then prev equals this. And then we can have this here, here, otherwise if prev is 0, and 0. Else print dot append okay, no, it's just this. And then at the very end, dot append group. We check if the last group is a 1. If so, we don't need this anymore. So -1 equals 1, like this. Then print to print. Something like this. I'm appending an extra 0 somewhere. I'm removing an extra 0 somewhere as well. So what is happening? I think I get the 1s right. I fail 0 behavior. Why? Oh, I never increment prev? That fixed this. Now this is broken. You have 1 0. One oh. What does this do? Our prev is 1. So we're filling this case. Just isolate it real quick. Expected is 0. And we have no outputs. Is 1. So we don't do this. Well, we should do this first equals false in any run of our thing. It still doesn't work. So it goes here. It goes here. Prev is 1. Line groups plus 1? No. This is, if current group is 0, we should append it. Let's run out groups. This is correct. Okay. So our decision here is important. Our prev here should be 1. this. I need to rework. If this works, I need to rethink the logic. It's not this. Wait, is it this? And then we swap these. No. Also, how do we fare with... Okay, that works. This doesn't work. So I think this is fine. I actually just need to add an else. I think either way I need to add this. That's not good. Okay. This case is failing. This is missing a 0. So my merging is not clean. It's logic here that's not clean. I want to say this is not needed then. It's my merging. So we check our previous value. If our previous value is a 1, then we append 0 because our current value is a 0. And we set our previous value to 0. Else, why? I guess how are we printing out so many zeros? So our previous value, okay, let's just walk this through. Our previous value for this is this one, 0 and 1. The first is true right now, so we go through here, and we append everything. It's 0, 0, 0, right? First is false. Now we group 2. Oh no, we don't do this. It's this. The independent behaviors. Set prev to 0. We don't touch prev here. We go through here. So, okay, we add if first. Else. Prev is equal to 1. First to false. Now, for our current group, if prev is 1, just appended a bunch of zeros. Prev is 1. Something's not right. The logic here is completely flawed. Not completely flawed, but it's pretty flawed. Kind of just want to rework it. Do we even need prev? We just need to check. Step 1. Check. Step 4, starting 0. We can do that very easily with this. Right? Okay. Now, we're gonna remove all of this first checks. I think we just rework everything here. On ring start. From start to len groups. Just double check this real quick. Two, 0, 1. So this is correct. Although I had starting zeros. So why did I print 0, 1? And it's because of this. There should be 0. Now I should print 1. It's correct. Should be 1, 2, 3. This is correct. Now, what we need to do is if group I 0 equal to is equal to 0 to print dot append 0, else to print dot else do nothing. And then at the very end, we do this for the last group. It's over. $35. Expected string, for instance. Okay. Isolate the case. This one. This case here. Expected 01. Double 01 Y. We don't have any starting zeros. We find a 0. Replace with 0. This is 1. This is 0, 1. Oh, fuck. I think I fucked up this logic then. I think the only part correct about this is this and this. Then the middle doesn't really matter. Because we can smush everything in it. Right? If it's 1 in between a ton of zeros, eventually negates into 101. just 0? Okay, so here's the issue right now. 1, 1, 0, 0, 1, 1, 0, 1, right? We only care about this, because there's no starting zeros, there's an ending 0, so we will always have this number in our end. And then everything else is just 0. If I have a 0 here, then we'll have 0, 0, 1. If I have a 1, 0, something like that, all this will be 0. It's just 1. This case still fails. So I'm very close. I just need to play with these cases. Okay. So it's all beginning zeros. If len groups is equal to 1, print group 0, 0, continue. This should handle this case. Now we need to handle this case. If this happens, this shouldn't happen. If they're starting zeros, that's not actually true. I should have these, and then an extra 0. So it's actually no, because if it's all zeros, it's actually this. Oh my god, this is actually so complicated. Now we're messing up this case again. 1100101. It's not this. So we go here. If we end in a Y, we do this. It's Jover. Because 1100 is O. We start with a 0. We start the 1, where we end in 1. Middle behavior. If len groups is greater than 2, do this. Two groups. I was saying do this anyway. We have 4 groups here. We need to check for a 101. We have 10, we just append 0. We have 3 groups. Okay, what cases do we have? We have 101, 0101, 1010. If this happens, 101 expected is a 1. Is 001. Then is 00. So we did the beginning, we didn't skip this, so we need to check here if len groups is greater than 2. We pass all these cases. So there's a 4th case that's not working, or else this should work. It's when it's 10. S equals 10. No special case, like 100 would also be um, what is this? Why are these passing now? But now this one's failing. We don't need to start anymore. I am so close. I am so close. What is wrong with this? Oh my god, this is so sloppy. But it seems to have passed every case. Where's the submission? Okay, got it, nice. Okay, I'm gonna ask AI to simplify this code, because surely it's not this difficult. It's edge case management. First things first, if all characters are the same, then we just print out S, continue, and then we can track a to print. We keep leading zeros. We should append zeros, and then I plus equals 1. So this is my leading zero logic. And then we should add a single zero. That's this. And then we should keep trailing ones. Alright, does this work? No. Yeah, this is just too aggressive, right? So I guess we can just account for this case by itself. If O1 in S and 1O not in S. So this is saying if we have this transition, because if we have this transition, we can make it 0. If we have only this transition, we can't do anything. So it's saying if we only have this transition, just return as is. Okay. Wow. So much easier. So let's submit this just to make sure it works. Then I'll just quickly review the idea. Why does it not show up on this? Not sure. Huh? It's over. Okay. So what it's doing is we check. There's two cases where we can't translate anything. Or we can't use our choose, right? We cannot modify if number 1 S is all same char. Number 2, we only have, or I guess we say we have no zero ones in it. Having no 0 ones in it, can I just do, yeah, yeah, this works. Okay. Otherwise, oh, so I should just do print S. Otherwise, append starting zeros, add a 0 since everything all O1 or all 101 are arbitrarily zero. Three, append ending ones. Okay, that's the method for this problem. Oh, this question took a while. Glad I got it though. An hour and 8, an hour and a half for this question. Alright, let's just keep doing questions. Oh, a picture. Nice. Alright, let me just send this to my buddy I was talking to. Hopefully he's proud of me. Okay. Alrighty, let's read this. A Ming's birthday is coming, and his friend A Mei decided to give him an integer array as a present. A Ming has two favorite numbers, A and B. He thinks an array is beautiful if its mean is exactly A and its median is exactly B. Median means middle, mean means average. Help A find a beautiful array so her gift can impress A Ming. Okay. The mean of an array is the sum divided length, yeah. Median is middle, so 2. If it's even, so it's sorted and then middle index. It's okay. It's dot sort, a dot sort, and then we check if even or odd. But first m equals n double divided 2 if len a mod 2 if it's odd return m am else return a m plus 1. Wait, return m minus 1. Zero, 1. Yeah, m, what the? M minus 1 plus a m divided by 2. Okay, that's the median. Right, and then we get two numbers. Length of the array. Wait, what's our input? A, B, and then that's it. Okay. I'll put length of the array and then elements of the array. Okay. We could just quickly we should low-key sort before anything. Well, we don't even have an array yet. Wait, that makes it kind of trickier. Where do we start? Where do we start with this? Where do we start with this? It's mean exactly A, median exactly B. Okay, 3 and 4. There are multiple solutions. Mean is average. If the average is 3, median exactly 4, it means middle. So we play out the middle, right? If it's 4, then average is 3. So first, if A equals B, print 1, print A, right? Exit. Otherwise, A is mean, B is median. Mean is 3. 5 plus 4 plus 3 is 5, 12, 15. 15 divided by 4. What? No, this is 13. 12 divided by 4 is 3. Okay. Twelve divided by 4 is 3. It is indeed. So this is a trick, huh? We abuse the median. We play around the median. The median is the average. This is sorted. Actually, -1, 3, 5. So if median is 4, let's just have 3 and 5. And this is 8. We need to now make this a multiple of 3, right? Or what if we just had 4 in the middle and we need to make this a multiple of 3? 5, 6. We need to add a number greater than 4. So like 5 is 9, and like 3. Well, we can add the same number, right? 3, 4, 5 is 12. This is 20. Divided by 5 is 4. Can I just use one number? Do I have a median of 4? 12 divided by 3 is 4. 16 divided by 4 is 4. 20 divided by 5 is 4. It's always going to be 4 I can't. So if I have 4, 8. Like the sum of the left and right have to equal 8, right? If I add the same number, I got 3. I can do 1, 7. It's some multiple of, we have to make some multiple of 8. We have some multiple of 8. We can have some 4 plus 8x divided by 3. Or divided by, yeah. Wait, no, divided by x plus 1 equals 3, right? Or no. If x is the number of numbers, no, yes, it's correct. X is the number of numbers. Five x equals 1, or negative 1. Wait, what? It's 5x equals negative 1. So it's saying, what? This formula makes no sense. So average is number of numbers sum 3x equals 4 plus 8 times x minus 1. This is the same thing, no? This doesn't make sense. One, two, three. Median, or A, average is 2. B is also 2. Okay. Now simply uh, 2, 3. Four, five, 6. I can always add zeros, right? Wait, aren't zeros kind of OP? 3, 0. Our average is supposed to be 2. So it's 3. Let's make it even first. So I need to add 5. Our sum is 8 now. Okay, so this makes me question another case. What if it's 2, 4, two even numbers? 4. Average is 2. Just split it, 2, 2. No, we can't split it. Bro, I hate how my backend shuts down. Maybe 2, 6. Average is 2, though. I need to use a negative number. Can I do this case with... So it's negative 1, 3, 5, 5. If I just do 4... Three, 4. Start with 4. Average is 3. I add a 5. That's 9. And a 0. There we go. If I do a different case, 2, 4. Start with a 4. Add a 5. That's 9. We should add a 6 to keep it even. 10. Negative 6. Negative 8. Wait. It's 10. We need to make it 6. Right. Now it's 4 divided by 3. No. We need to make it 6, so this is negative 4. Now it's 6 divided by 3 is 2. Okay, this makes it so much easier. We could very much add a 5. This is 9. And then 9 minus x equals 2. 9 minus 2 equals x. So we do 7. That's not right. 9 minus x. 9 minus x over 3 equals 2. So 9 minus x equals 6. Which means x equals 3. So negative 3. Yeah, so can I do 4, 4? 8. And our target is 6. And our target is equal to a 3 times a. Right. Which in this case is 6. So our third number is 2. Negative 2. So print b target minus target minus target. It's target minus b plus b. Wait, 3, 4. 9. Yeah, this works. Now, let's try 4, 4, negative 2, 8, 7, 6, divided by 3 is 2 is correct. Let's try 3, 8. 8, 8, negative 7 is 16, 20, or 16 minus 7 is 9. Yeah, that works. I think this works. Submit and see. Gosh, this one took me another 30 minutes. Come on, rock your body. Rock your body. Come on. Rock your body. Rock your body. What's taking us so long? Wrong answer. Okay. 114 is incorrect, you're saying? The mean is average. Oh, I never printed out this. There we go. I gotta remember to read the problem. Alright. It's not too bad. Let's do like a couple of 800 for speed. Because low-key, I should be able to be getting these in under 5 minutes. I still think I take too long on them sometimes. So I'm gonna pull up a timer. Stopwatch. And then I am gonna... What was I gonna do? I forgot. I'll just do cautions. Oh, there's a diff 4 tomorrow. Should I do it? Or in 2 days? Sunday? April 4th. in 30 hours? Right, it's Friday. Yeah. Oh my god, I'm getting my days mixed up. Okay, Saturday is a diff 4. Let's do it then. What is stopping me from doing this contest? Absolutely nothing. I should do it. Okay. Um, let's solve some problems then. Okay, ready, starting now. You're given an integer n, call an array A of length n good if for all indices ai times the next one is less than 0. Okay, so the array is going to have negative numbers in it. The product, yeah. All subarrays with length at least 2, sum of the elements is positive. Okay, so there's at least one positive integer in the array. Okay. A good array A length n is better if the absolute value is smaller than, okay, got it. What do we take in? T, and then we take in n. All right. So first test case, because a1 times a2 is less than 0 and sum is greater than 0 satisfies two constraints. Show that the corresponding 1, 2 is better than any other good array of length 2. Okay. Negative 1, 3, negative 1. Negative, negative, sum. So n is the length of the array, right? So if it's 4, we should go back down to 2. It should be negative 1, 2, negative 1, 2. Is that correct? Is positive. Negative, negative, this satisfies constraint 1. Constraint 2 is all the sum of all the elements is positive. This is correct, but it's too positive. Can I do this? Or like negative and 0. So okay, so why can't I do negative 1, 1? It's negative. Sum is 0, which is positive. It has to be greater than 0 to be positive, okay? One, like this. So for 3, so for 5, it'd be negative 1. Lexicographically smaller. So So we should do -1, -1, 2, like the biggest numbers at the end. So for 5, we should do -1, 1, -1, 1, -1, or no, this is 4. And then we should do 5. Right? Sum is, no, it should just be 0, 0, 1. Why is this 2? This is for 4, right? 0, 1, 0, 1, 3. For 3, we can do -1, 1, 0. Why can't it be this? Because it's 2 evens touching. -1, 1, -1. So this doesn't work. It's 2 evens touching. -1. It needs to be like this. And then I need to increase this to something. This is 3. 0. Needs to be 3. So if it's odd, if it's even, we do seal and divide by 2 plus 1. Of these, 4 divided by 2 is 2 plus 1. And then we do, wait, 4. Do start off with -1, and then we do 4 and divide by 2 minus 1 iterations. Alright, because 5 would be, or 6 would be -1, or -1, 1, -1, 1, -1, and then 5. This is 0, 0, 2, right? So this is, have this, 1 iteration, 2 iteration, this one's 1 iteration, and what's the smallest we can have is 2. 2 is 0 iterations. 3 1 4 1 5 2. Okay, 3 is 0 as well. 4 is 1, 5 is 1, 6 is 2, 7 is 2, 8 is 3. So iterations is equal to n divided by 2 minus 1. Yeah, I think so. And then for I in range iterations to print dot append 1 to print dot append -1, and then if in mod 2 to print dot append 3 to print dot append -1, else to print dot append 2, print to print star. Okay, this took me 11 minutes. I'm not going to stop it until I get it accepted. I didn't. Fail 4. How does this fail? 0. Okay, sum is 1. Why does this fail? Can I get a smaller array? Three. Why is this 3, -1, 2? -1, 3, -1. Did I misread the problem? For all subarrays with at least length 2. This needs to be at least 2. For all subarrays. This will be 0, so this needs to be at least 3. Okay. I see what's happening. I in range in to print dot if I mod 2 equals 0 to print dot append -1, else 2print.append in minus I. Print star. It is 3. I is 0. I is 1. I is 1. I minus 1. Right? There should be 4. Should we just generate it backwards? No. Just append 3. And we just check if -1, if 2print -1 goes to 3, 2print.pop, 2print.append 2. Here, we got it. Why did that take me 17 minutes? Alternating series. Not much difference when the series n equals k and n equals k plus 1. What does that mean? Track the series left to right greedily. Okay. We see the first condition is equivalent to the elements of A being alternating, yeah. We claim that any positive element must satisfy this. Furthermore, if yes, I agree. Okay, so basically I think what's going on is we look at this case, right? This, in this case specifically, is odd. We alternate, and it must be at least 3. this number because we're going to have at least 2 ones, right? Now, if we have an even case, it's going to end on a positive number, and we can have a 2 instead. So if we had 4, it'd be -1, 3, -1, 2, right? So with all subarrays at least length 2, well, then we can only have at most 2 destructors, right? Why can't this be wide? Because this is 0. You're right. This has to be at least 2. Okay, so if we have an odd, then we group them by -1, 3, -1, because 3 takes care of this subarray here, right? So if we have a 3, this subarray is positive, have a -1, then boom, this is positive. Now if we have an even, we could put a 3 again and it would still work, but we could get away with 2 because of this subarray. We just need to maintain this subarray, because we move on and then we already have a 3. And this 3 maintains this subarray, which means automatically this is maintained. That makes sense. Okay, let's take a look at the code. Lambda, okay. I think they're just using this take an input. Oh, they just replaced the last one. Yeah, we could do that. We could do to print -1 equals 2. There we go. Alrighty. It is 3:20 a.m. and we've been recording for 2 hours. Hopefully I can get longer videos in again. I do really want to do that. I need to lock in better for Codeforces. But if y'all enjoyed the video, be sure to like and subscribe. I will see y'all guys next time. Bye.